Welcome to Leetcode JavaScript, a channel where we solve every single Leetcode question using JavaScript. Today we have 2256 minimum average difference. This is a medium question. So you're given a zero index integer array num, so like that. The average difference of the index I is the absolute difference between the average of the first element I plus 1 of nums and the average of the last n minus I minus 1 elements. Both average must be rounded down to the nearest integer, and you must return the index with the minimum average difference. If there are multiple such indexes, return the smallest one. Now, there are a couple notes to be taken when we consider this problem. First is absolute difference is the absolute value of a difference of two numbers. So, for example, if we have 1 minus 4, that's negative 3, but it ends up being 3 because we do take the absolute value, so be aware of that. Also, the average of n in this case is the sum of all the elements divided by n, where n is given by the integer division, which is important because in JavaScript that's not the default. And also the average of 0 is considered to be 0. Now let's take a look at a couple of examples. This problem really isn't all that complicated. And what we have here in the first example is we take the first element and we take the average of one element. 2, it's going to be 2. Then we take the average of all the rest of the elements and we get 2 and 5. We do 2 minus 5, the absolute value that is going to be 3. And we repeat, just changing the size of the left and right portions all the way up to the end. And we find out that index 3 is when we have 4 minus 4, which turns out to be equal to 0. And that's going to be your answer. It's going to be 3. That's the index. So when trying to solve this problem, you may realize that we are computing the average many times. And generally speaking, computing the average of something takes all of n time. And if we just follow this to the logical consequence would be this has to take a list of n cubed because we are taking n times the same times the average, but we actually don't really need to do that. We are going to be pre-computing those things. And what is the correct way to pre-compute this? Something that you may try to do is memwise using some sort of dynamic programming approach, but that actually is not the most efficient in this particular case because memoization does take all of n times, so that's at least going to be n squared in that case, which is better than n cubed, but it's not the best we can do. We can actually do this in linear time by making the computations actually be O of 1, being in constant space, or time rather. And the way to do this is by using a prefix sum. We are going to be using an array to do this prefix sum. And prefix sum is a particularly useful thing when we're trying to compute many things that usually would take linear time. And it really isn't that complicated, but it is something that many people aren't super familiar with. So I'm gonna show it to you guys here. So we start with a prefix sum array. Let's call it pre, and then we're gonna do a for each loop of n of n nums, and we're gonna do pre.push. It's gonna be pre of pre.length minus 1 plus n. And of course, the first time we have this array, it's going to be empty, so this is going to be undefined. And to prevent that to throw an error, we're going to use or 0. So the default case is 0 when the last element is not defined. But generally speaking, we take the last element that we have and we sum m to it. And let me console dialog that for you guys so you can see what we're actually doing. So we do console dialog pre, and here's what we have. Of course, this is not the answer, we're just simply trying to look at the std out. And again, prefix sum is relatively simple, where you take each element and you sum it to the sum of the previous elements. So we start with 2, plus 5, that's going to be 7. Then we have a 3, plus 7 is going to be 10, plus 9, plus 3, but 3. And that's how we get this prefix sum array. Now that we have computed this, and computing this does take O of n time, of course, we can compute all the averages in O of 1 time, which is just fantastic for this problem. So we're just going to be computing them right now. We're going to start with min. We're going to call this in if I can spell it right, yeah. And we're gonna have the answer, and that's gonna be initially -1 because it's an index, and -1 cannot be an index, just to be safe. And we are gonna be using a simple for loop that you probably are familiar with. We do let I equal 0, I equal I less than 3.length. We could use nums length here because the length of prefix and the nums array is actually the same. Doesn't really matter, but we are going to use pre here just to be absolutely clear what we're iterating through. And we're going to have a temp variable. Now here's what we're going to compute. Say for any given number, for example the second element, we are going to compute the average all the way up to the second element, and then we're going to compute the average from the next element onwards all the way to the end. Then we're going to take the difference and the absolute value of the difference. So let's do this by parts, just so we're super clear. So we need to take pre-I divided by I plus 1. Super simple. For example, if we were to take the average of the first two elements, we take the prefix on those two, which in this case is 7, and the index here is 1, but we do have two elements, so that's where we have I plus 1. But remember, we actually want to have integer averages. So we are going to be using a float function, and I want to show you this very neat trick I learned recently. You can use this double not operator. This is the bitwise not operator. And when you apply it twice to a integer number, it gives you the math.float function. Only works for positive integers, by the way, not integers, number rather. So this is just a neat little trick. And we're gonna do this minus, and we're gonna take pre.length minus 1. So we're gonna take the last element, but we are gonna subtract pre-I, because just think about it. If we were to take the last element here, it would be 27, and we take again all the elements except 2 and 5, so we do have to subtract 7, which we have pre-computed here, so we just do 27 minus 7, that's going to be 20. So far so good. Now we are going to divide this by pre.length minus I plus 1, and again relatively simple. Pre.length is the number of elements, and I plus 1 is the elements that we have on the left. So we just, in this case, do not take account the first two elements, and we do take into account the rest. And of course, we are going to be using the bitwise operator again, double not, which is just a shorthand. And this is not everything, because we are missing, remember, the absolute difference. And this is a problem, as in many people encounter when trying to solve this problem. That's why many people didn't particularly enjoy this problem when it was the current week problem, contest week problem, because yeah, I just have a bunch of caveats that are not super easy to deal with. And finally, we do have math.apps here. And this may look a little messy, and I do apologize for that, but essentially we can separate this by parts. Here's the first part where we take the average all the way until the current element, and here's the second part where we take the average of all the elements all the way up to the end. And now we have to check whether temp is less than the current minimum, and if that's the case, we assign min to the temporary variable, and we send ends to I. And the last thing we have to do is return ends. Now let's try to run this code. And it is accepted. Let's try submitting this code. And there you go, it is accepted. Now let's try to do a time and space complexity analysis. So for time, this is O of n, the echo of n. Why? Because we have a for each loop that iterates to nums once, and we also have this regular for loop that iterates through 3 at once. That's simply going to be O of n. There's nothing complex about it. Now about the space complexity, we are going to have O of n also, because we do have this prefix sum array, which has that same length of nums, so that's the additional space that we're using. And that's everything for today. Thank you so much for watching. Do not forget to like and subscribe.